Okay, so remember, we are doing the application problem. I've started the timer for 4 minutes for you to start doing your application problem. Remember, use your cube strategy to help you solve it. Okay? Then we're gonna go through it together. Okay, you should be finishing it up. Alright, let's come together. So, Finn, read this for me, please.
The Napoli family combined 2 bags of dry cat food in a plastic container. One bag had 5-6 kilograms of cat food, and the other bag had 3-4 kilograms. What was the total weight of the container after both bags were combined?
Okay, so they're telling us that this family had how many bags of food? Say it together. 2. 2. One had how much?
5-6.
And the other?
3-4.
Okay, so what is the first thing I should do? Yes. Circle the numbers. So I'm gonna circle 5, 6, and what else? 3 fourths. Good. So what's my next step, Naomi? I'm gonna underline my question. What is my question? Good. What was the total weight of the container after both bags were combined? Good. Next, so what do? What keywords should I combine? Should I box? Sorry.
What's the total weight?
The total weight, okay, because why is that important? Why is boxing this important?
Total weight.
Because this is what we're trying to find, right? Yes. What else is important, Isaiah?
Combine.
Why is that word important?
Because they're putting two of the bags together.
And when you see a word like this, what do you think we're gonna do?
Add.
We're gonna what?
Add.
Good. Any other words that we should be boxing? Christian, container? That's just kind of like knowledge, right? It's just tell us what we're putting it in, right? Yeah. No? Okay. So good. So we know we box what we're trying to find, right? The total weight plus what they're telling us how we're gonna find it, right? Why? Because we're gonna what? Add. Okay. What's next? What do I have to do now? Yes.
You will have to box.
We did. We box keywords.
We will have to evaluate the information.
So what is it? What's important about this?
You should find out what if it says combine. You have to find out what the total weight is.
Okay. So what expression would you create to find the combined weight? Show me on your whiteboards. Show me on your whiteboards what expression you would create to evaluate this application problem. Good. Yes. 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 No, we're not finding that yet. I asked you for the expression.
Oh.
Yes. 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 Yes, sir. Yes. Brayden, let me see. Yes. I'm not asking you for that just yet. I'm asking you for the expression. Okay? The expression. Yes. So, Julian, if they want us to find the combined amount that they put in this plastic container of cat food, what would you do? What would be your expression to represent that? Okay, you would add, what would you add? 3 fourths plus 5 6. Okay? That's what I mean when I tell you show me the expression, right? Now, you showed me something even better. Show me how many, when I'm using my rectangle model, how many parts are in this hole? 4. How many should be shaded in? 3. What about here? How many parts are in this hole? 6. How many should be shaded in?
5.
Yes. Hold on. Okay, so then what do I need to find next? Everybody say it with me. 1, 2, 3.
LCM.
I need to find the LCM. How do I do that? What's the first thing I should do? Yes, Trishan.
You have to find the least common multiple.
Okay, so what do? I have to list what? The multiples of what? Of 4 and 6. So altogether, for 4. 4.
8.
Do I keep going? Okay. What about 4, 6 altogether?
12.
Okay. So why don't I keep going here?
Because 12 is our least common multiple.
12 is our least common multiple, right? So what do I do now? What am I going to do now, Phineas?
You have to find the equivalent fraction.
I'm going to create equivalent fractions, or what do we call it also? Rename. We're going to rename or create equivalent fractions. Thank you. So let's do that. So I have 3 fourths is equal 12, right?
4 times
So, what do I need to multiply here to create an equivalent fraction? Ileana? 3. And whatever I'm doing to the denominator, I'm doing to the
numerator.
right? 4 times 3 is?
12.
3 times 3 is?
9.
Okay. Next I have 5, 6. What am I doing here?
I 12 on your denominator.
What am I multiplying by?
2.
2. And whatever I'm doing to the denominator, I'm doing to the
Numerator.
5 times 2.
10 times.
Good. Now, what do I do next? Isaiah.
Add it into a mixed fraction. Or
So add them together, right? What am I going to add together now?
9 12 and 10 plus 12.
9 12 plus 10 12.
Which equals 1 and 7 12.
So what is that together? 9 10s plus 9 12s plus 10 12s is what?
19 12.
19 12s, right? But I can split this up, right?
And so 1 and
So this is 12 12s, right? And what?
and then 7 12.
7 12s, right? So this is equal to what?
1.
1. So like Isaiah said, it should be what? 1 and...
So
Give me a thumbs up if you got it. If this is what you got. Thumbs up. Huh? Oh, in kilograms. Sorry. Thank you. You got a label. Thank you. Give me a thumbs up if this is what you got. Show me. Yes? So? We were getting there, some of us? Yeah? We need a little bit more time? Yeah? Okay. Alright, so this is the process we take, right? When creating these fractions. Yeah? Julian? What I see you thinking. What's going on?
I was just looking at it.
Okay. Do you get it? Were you here? Did you get to this point?
Yeah.
Okay. Are we good? Yeah? Okay. So, let me fix this. Let's move right along into our notes. Okay. Okay, so our learning target for today is I can subtract fractions with unlike units by creating equivalent fractions. Why is that important? So that I can express fractions using an area model and number line. You know you are successful when you can subtract fractions with unlike units 80% of the time, right? Okay, so let's look at our objective for today, okay? So our objective today says to subtract numbers between 1 and 2, right? Well, what they're telling us today is that we're gonna
subtract whole numbers.
we're gonna subtract mixed numbers.
Mixed numbers.
Yes, we're gonna subtract mixed numbers, right? So, tell me, Isaiah, what is a mixed number?
1 and 3 12.
A mixed number is, okay, good.
Mixed number is like a whole and a fraction.
It's a whole and a fraction. So 1 and 3 12ths is a mixed number, right? Because it has, like I said, a whole number and a fraction, right? Okay. We good? So we have a whole number and a fraction, right? But what they want us to understand today is that there will be times where they'll give us problems that look like 1 and 3 12ths minus 2 fourths, right? Well, how do we do that, right? We know the process to subtract fractions with unlike denominators, right? What's the first step that we do?
Also,
What do we do first?
we do the LCM.
What's the LCM?
It is to find the lowest
The least and multiple, right? So we find the LCM, then what do we do? After we find the LCM, yes, Trisha?
We would have to multiply it.
No, what is it called? What do we call it? What is it called? That process that we do, what is it called? Yes, we create equivalent fractions, exactly. Then what do we do, Nicholas? Once we rename them, right, because equivalent fractions is renaming, what else do we do? Then we subtract or add or solve, right? We solve. Okay, good. So what we're gonna do today is exactly that, but the difference is that we're gonna be working with mixed numbers. Okay? So let's get started. So we have 1 3/12, right? So I want to draw a picture to represent 1 3/12, right? And one that represents 2/4, right? So how many parts should be in each of these boxes? 12. Why, Isaiah? Why should there be 12?
Because 12 is our denominator.
12 is our denominator? Yes. So okay. So for 1 3/12, how many should be shaded in here?
12.
How many should be shaded in?
12.
All of them, right? All of them should be shaded in. What about for 3/12? How many should be shaded in, Donna, for 3/12? 3, okay. And what about for 2/4? How many parts are in this whole? 4. And how many should be shaded in, Daniel? For 2/4? 2. Okay. I'll give you a minute to catch up. How would I create an improper fraction to represent 1 3/12? What would be my improper fraction for 1 3/12? If this is 12/12 and this is 3/12, what is my improper fraction for this? 16/12, right? Okay. Oh, sorry, 15. Yes, 15/12. Thank you. 15/12. 15/12. How many parts are in this? This?
How'd you get 12 close? But there's 1 12 and plus a 3.
Say it again.
Wait, so the 1 3/12 and
1 3/12.
then the whole one is 12 and then plus the 3
Is what?
numerator isn't it like 15?
Yeah, that's why it's 15/12.
No, besides you're not adding.
What's your question?
Because I thought you were adding the 2 4.
No, we're not adding that yet. Okay? So, if I have 15/12 here, right? And I think about this as 3 minus 3/4, right? What do I have to do?
Find the LCM.
Find the LCM. What would be the LCM? Show me on your whiteboard. What would be the LCM for this? For both of these, what would it be? What would you have to find? Tell me. What's the LCM? On your whiteboard. Show me on your whiteboard. Yes. 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 No. Yes. 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 So if you said that the LCM should be 12, you are absolutely correct. Okay? Do I have to create an equivalent fraction for both of these?
Yes.
For both of these?
Yes.
No, why?
Because one of them is already
Because one of them already has 12 in the denominator. So, if I'm doing 3/4, what is the equivalent fraction that has a denominator of 12? Yes. Sorry, 2/4. If I'm doing 2/4. I'm doing multiplying by 3, you said? Okay, and whatever I'm doing to the denominator, I'm doing to the numerator. So 2 times 3, 6. Okay, so we have 2 times 2/4 is equivalent to 6/12, right? So now I have 15/12 minus 6/12, yes? And what is that? Show me on your whiteboard what that would be. 15/12 minus 6/12. Nine what? No, check your math. Yes. Check your math. Yes. Yes. It is 9/12. Okay. So that's one method of how we can do this, right? How we can subtract mixed numbers, right? Create equivalent fractions and subtract, right? Okay. Now, the other way they want us, this is method 1, right? Well, what if I had 1 and 3/12 minus 2/4, right? What if I had that? 1 and 3/12 minus 2/4, yeah.
what did you write right there?
Where?
The,
Right here?
no, bottom.
This is method 1, method
Oh.
2. Okay? This is one way of doing it. This is gonna be the second way we're gonna do it. Okay? So again, I have 1 and 3/12 minus 2/4. I'm gonna draw my rectangle models to represent that. What was our LCM for this?
12.
What was it?
12.
Okay, our LCM was 12, right? Give you a minute to catch up. 12ths minus 2/4, right? We know that this, when we create our equivalent fraction here, what was 2/4 equivalent to? What was it? What was the equivalent fraction of 2/4, Julian? What was the equivalent fraction we created with our new denominator?
12.
It has a denominator of 12, okay. So how many parts are shaded in here?
2.
2. And our new denominator is what?
3.
No. When you created an equivalent fraction for 2/4, what was it? With your new denominator of 12, what was it? You multiplied by what?
3.
Okay. So what? 2 times 3 is what?
6.
Okay, so what's your new fraction?
6 12.
6/12. So I have to split this up into 12s, right? Yeah.
Is it 6 12 because 2/4 is half of, or is half 6 12?
Exactly. Yes. Okay, so this is technically now 6/12. This is 12/12 plus 3/12 minus 6/12, right? Can we all see that? You need me to move it up. How many should be shaded in here?
Where is this?
Where?
After total.
This is an addition
No,
sign.
after total.
3/12. How many should be shaded in here?
Double thing.
The whole thing should be shaded in here. How many should be shaded in here?
3.
3. So all of this is shaded in. 3 are shaded in here. Well, how they want us to approach this, right? So when we see 12/12 plus 3/12 minus 6/12, what they want us to think is like, well, we don't technically have to take away from this here first, right? They want us to take away first from the whole.
Oh, I see.
Do you see that?
Yeah.
So they want us to take from the whole. So if I have 12/12 minus 6/12,
Oh.
what is that?
6 12.
6/12. But I still have these 3/12. So what do you think we're gonna do with it? We're gonna add it into the end. Okay?
6 12 plus 3 12.
Yes. So again, what do they want us to do first? Take from where?
12 12.
Take from the whole, right? So we're gonna take from the whole, which is 12/12, right? And that will give me what? 6/12, right? And then what are we gonna do after? Add the whatever we have left over, right? Okay. So we have 12/12 minus 6/12, and that's what?
6 12.
So 12/12 minus 6/12 will give me 6/12. And then what are we gonna do with this? We're gonna add the 3/12. Good. And what is that? 9/12. Is that the same answer we got here?
Yes. It was faster.
Yes.
We have P, right?
Yeah. 9:15. Okay. All right. Any questions so far? Yes. Okay. What are you confused about? Tell me.
Because
Okay, but you gotta pinpoint where. What? Okay. Tell me where I lost you. I'm gonna multiply. Okay. Then sit up. Okay. So, Jayshawn, this is 1 and 3/12, right? You see my two rectangle models? Yeah. I have 12/12 plus 3/12, right? That was the same thing as 15/12, yes? Okay. So what the second method wants you to think about is as, and this was now 6/12, right? Because we created the equivalent fraction up here. Well, I did the same thing here. Yeah? Okay. What they want us to think about is instead of us taking away first these 3/12s, these 6/12s from these 12s here, from this small fraction here, they want us to take away from this whole big fraction here. So we would take away 6/12s, right? So I have 6 here and I need to take those away from these 12/12. So I have 1, 2, 3, 4, 5, and 6 that I'm taking away, right? And what would that leave me with in this whole? 6, right? But look, there was still another part of this. There was still another part, right? I still had 3 more. So what would you do? Well, this one still has shaded in, right? This part, how many were left in this hole? After you took away the 6. Okay, and then this, how many were left? How many were shaded in here? Because you had 3, right? So what are you supposed to do? Add them. Does that make sense a little bit more? Okay, I think you're a little confused. You want to ask me another question? Okay. Oh, you do? Are you sure?
Yeah.
You should pause it. Okay, yes. What are you confused about, Daniel? Yes. It's the same thing, just 2 different ways of doing it, right? And what do we always say? Math has what? More than one way of doing things, right? And there's more than one way to get the what? The same answer, right? Yes, Isaiah.
Okay, so how do you know? Or it's just 2 methods, right? You can still do it. But like
You can do 1 or 2. Yes.
Why don't we just solve 1/3 12s as 15 12s?
We can. I was just showing you a different way.
Oh.
Yes, we can.
Because that's what I thought of doing.
You thought of making it an improper fraction and then subtracting?
Yeah.
You can do it that way. Yes, Daniel. Yes.
There isn't that much of a change between method 1 and method 2.
I don't know. That's a good question. I don't know why there's not much of a change. It's just looking at it in a different perspective, right? It's giving us different ways of doing it, right? Daniel,
So we had to grab a bug?
I said yes, right?
Or then you have like a
Yes, we will. We will be, so that you can see it. Just in discuss it. Okay? Yes? We're good? Okay, let's move on to our problem set. Take out your learn book, you're turning to page 41. Okay, so it says, for the following problems, draw a picture using the rectangle fraction model and write the answer. Simplify your answer if possible. What words stand out for us here? What words are standing out for us?
drop it.
Draw a picture. Okay, so we're gonna draw a picture. What else? Crystal. Simplify. What does that mean, Crystal? Say it again. Yes, to make it the smallest form of the unit, right? What else stands out to you, Leanna? So we're gonna do a rectangle fraction model, yes. What else? Daniel, sit up. What else? Jishan.
Write your answer to
Yes, we're gonna simplify our answer. Good. I think that's good, right? So we're gonna draw a picture, right? A rectangle fraction model to be exact, and then we're gonna simplify when needed, right? Good. Okay. So it says 1 1/4 minus 1/3. Show me on your whiteboard if I were to be drawing a rectangle fraction model, what that would look like for 1 1/4. Show me on your whiteboard what it would look like for 1 1/4. Your rectangle fraction model. For 1 1/4. I don't want 1/3. I want 1 1/4. Show me what it would look like. Think about how many rectangles there would be. Good, Alexis. Look at what you're shading in. Yes, Danny. Good idea. Yes. 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 Good job, Ariana. You got a head, but good job. Yes. Good. You're missing something.
Have you like extra whiteboard? Seems to like scratch is bothering me.
Good. Yes, Kevin. Good. Okay, so if you did this for 1 1/4, you are correct. Sit up. Sit up all the way up. Okay? Now show me what you would do for 1/3 on your whiteboard. Show me. For 1/3. What would your rectangle fraction model look like? Good, Jason. Yes, Alexis. Yes, Danny. Yes, Nicholas. Yes, Eileen. Yes, yes, yes. Yes, yes. Yes, 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 yes. 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 Good. Yes. Good. Yes. Alright, so if you said one-third, great. Are we good? Are we all in agreement that that's how our rectangle fraction model should look? Yes? Okay. Now, on your whiteboard, what do I need to, no, now tell me, what do I need to do next in order to be able to subtract these fractions? Yes, Ariana. I need to find the LCM. Tell me on your whiteboard what the LCM should be. Tell me on your whiteboard what the LCM should be. Show me on your whiteboard. Think again. Yes. Keep them up. Still waiting for some. Okay. Alright, good. If you said the LCM is 12, you are correct. Why do we think it's 12? Why do we think it's 12, Phineas?
Because if you go over the multiples of 4 and 3, 12 is the first multiple that you don't have.
So you listed your multiples, right? You thought of you skip counted, right? You said 3, 6, 9, 12. Then you did 4, 8, 12, right? And you said, hey, 12 is the least common multiple, right? Yeah.
Why don't you go for 4 first?
But 3 doesn't go to 4.
No, he's saying, wouldn't you list the multiples of 4 first? Yeah, that's what he's saying. Either way it's fine, but you can. I mean, I see why you did that, right? Because you say, oh, the first whole is 4, right? Okay, yeah, that makes sense. Okay, so our LCM is 12. So, how many parts are going to be in each of these holes now? How many parts? 12. Yes, so I'm going to split these up into 12. You see that? Okay, so what do I do next? Tell me what I do next. Danny, what am I going to do next in order to be able to subtract these?
You are going to rename them.
Rename them. Okay, so I have, this is going to be what? 12 twelfths, and this is what? 1/4. This is 1/3. So I'm going to rename 1/4, right? What is that? 1/4 is equal to something over 12, right? What am I multiplying by, Alexis?
3.
3. Whatever I'm doing to the denominator, I'm doing to the
Numerator.
4 times 3 is 12. 1 times 3 is 3. Okay. So now this is going to be what? 3/12, right? 1/3 is equivalent to what over 12? Liana, what am I multiplying by? 4. And what am I doing it just to the denominator? I'm doing it to the numerator as well. Right? So 3 times 4 is 12. 1 times 4 is 4. Okay. So now this is equivalent to what? 4/12, right? Go.
Why did you put 1 and 1 points?
Because we already have 12/12s here, right? Because that's representative of this one. So this is, right? Yes? Okay, what are we confused about?
The fraction model.
So you have 12/12s here, right? So how many are in your whole rectangle fraction model? 12. Okay. So 12 are my rectangle fraction model. How many are in this whole thing here? 12, right? And how many should be shaded in?
3.
3, right? Because we have 1 and 1/4, right? But we created what? What did we do here, Brayden? What do we call this? But what do we call it? What do we call this thing that we do here?
Rename.
We renamed, or we created what?
Fraction.
Equivalent
Fraction.
fractions. Okay, good. So we renamed the fraction to be 3/12, right? So now that we renamed the fraction to be 3/12, how many parts are in this whole? How many parts are in this whole now? How many?
3.
No. That's how many would be, how many we have, right? Of the whole, but how many are there total in this whole rectangle? Look at your fraction. Which number tells you how many parts are in your whole fraction? Make up one. What number? Is it the denominator or the numerator?
The denominator.
Okay, so what does your denominator tell you? How many parts are there?
12.
12. So now there's 12 parts, right? And how many should be shaded in? Oh. How many should be shaded in? So now you're telling me that there's 12 parts in this whole, right? Because your denominator is what?
12.
12. Okay, so then what do we do next? What does the numerator tell us? What does it tell us? How many to what? You want to ask a friend to help us?
Yeah.
Okay, ask a friend.
Jishan?
What does the numerator tell us, Shishan?
It tells us how we're gonna it's gonna tell us how we're gonna add it, subtract it.
No.
Oh, it shows us the fraction that we're gonna add.
No.
It shows us the number that we're going to be adding or subtracting.
It shows us the number that we have what? To what in our... Okay, go ahead. It has what? It gives us a number what? What does the numerator tell us? It tells us how many to what? or add or subtract, or even what? Shade in, right? So, if I went from 1/4 to 3/12, these fractions are what? Equivalent, right?
Yeah.
So, do you understand that part? How we
Yeah.
created these fractions now? Okay. So now we have 1/3 and that's equal to 4/12. Yeah.
Oh, I was gonna say now we subtract it. There.
Yeah. Okay, so now, right? Now knowing what we know, right? We know that if I'm gonna cover this up here and this one here. Right? So I know that these two are together, right, Brayden? You're following me? And this I'm subtracting, right? 4/12. Now, so I have 12/12 plus 3/12 minus 4/12. Well, what does our second method tell us to do? What does it tell us to do?
Subtract 12 and 4/12.
Subtract from the whole first, right? So I'm gonna cover that. 12/12 minus 4/12 is what?
8/12.
8/12, right? So 12/12 minus 4/12, right? Is 8/12. And Brayden, what do I do with this 3/12? I still have that, right? It doesn't go away. What do I do? After I've subtracted this and this together, right? What do I do with this 3/12? I add the 3/12. And what do I get? 8 plus 3/12 is what?
11/12.
11/12. Absolutely correct. Okay? We're good? Okay, let's try using method 1 now. Okay, so I have 1 1/5 minus 1/3. Show me on your whiteboard what your rectangle fraction models would look like. Go ahead. For the whole expression. Show me on your whiteboard. I'll tell you when to put it up.
Wait, like,
For the whole expression.
Oh.
Okay, for the whole thing. You're showing me for the whole expression. I'll tell you when to put it up. You're done? Flip your whiteboard.
Should I do that at 1:40 or 3:30 or 3:40?
Today?
Because it's daylight saving time. They're still gonna get out at 2:40.
Hold on. I will tell you when to flip it over. Who needs another minute?
How come it sounds like you're not doing TP?
We are.
It doesn't sound like it.
It has nothing to do with math, guys. Nothing now. Does it have to do with math?
No.
Then we'll talk about it later. Does that have to do with math?
So method 1 is just like, well, I'm not example 1. Method 1 is just like 12 plus 3/12, and then you minus the 4/12.
Exactly. You would create a what? Improper.
Improper fraction.
Exactly. Yes. All right. Show me your whiteboards in 3, 2, 1. Good, Daniel. Yes. Good. Yes. 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 Yes, Daniel. Yes. Good job. Yes. Okay. Good. Yes. Good. All right. So, how many parts should be here? in here, how many parts?
5 and then
How many should be shaded in here, Brayden? What is this fraction? This is representing the 1, right? And this is representing the 1/5. So how many should be shaded in?
the whole thing.
The whole thing. Eileen, how many should be shaded in here? 1. Good. How many parts are in this?
3.
Donna, how many should be shaded in? Okay. We good? We see this? Okay. Now, on your whiteboard, tell me what the LCM should be. Show me, hold it up.
What's the LCM?
Mhm. Yes, if you said 15, it is correct. Your LCM is 15. So, yes. Yes, 5 times 3 does equal 15, but that's not why 15 is the LCM, right? What did you do? You listed your multiples, right? So you went 3, 6, 9, 12, 15, right? And then you did what? 5, 10, 15? Okay, good. And then you said, those two are what? Multiples of what? Of 3 and 5. 15 is a multiple of what? 3 and 5. Good. So, tell me, what is the fraction that's represented here? What's the fraction that's representative of this whole? Isaiah, what's the fraction?
15, 15.
No.
Oh, 5, 5.
5 fives. Okay. And here is 1/5, right? And this is 1/3, right? Okay. But we need to create equivalent fractions, right?
Yeah.
So, what is my new denominator going to be?
15.
15, right? So, how many parts am I going to switch my rectangle models to?
15.
So, each of them have to have how many?
15.
15. So show me the equivalent fraction on your whiteboard of 5/5 for this, with our new denominator of 15. What would be my new equivalent fraction here? What would be the equivalent fraction here? Yes. No. Think about it. You're multiplying, not adding. Is that a 1 next to the top number? Yes. 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 Daniel, how do you create equivalent fractions? Yes, Crystal. No. So, I have 5/15s, right? And I need to create an equivalent fraction of 5/5 to 5/15. What should it be? What am I multiplying by here? 3. Whatever I'm doing to the denominator, I'm doing to the, right? So 5 times 3 is? 5 times 3 is?
15.
So my equivalent fraction is 15. Not 3/15, right? A lot of you had that, okay? 3/15s, it's not 3/15, because they thought it was just we're multiplying. Remember, we multiply to create an equivalent fraction, that's why. Okay, do you see that? Daniel? Why is it not 3/15s? Why did you think it was 3/15?
Because it says to create equivalent fractions of 3 times 5 being 15.
But you only did that to the denominator. What about the numerator? You forgot to do it? Did you forget to multiply the numerator? So then what? Why did you think that? I want to know. I'll give you a sticker. Tell me. I want to understand. Tell me why you thought it was 3/15. You weren't the only one.
Because that's why I put it that, because 5 times 3 is
It's 15. Okay.
he said to create equivalent fractions.
Mm-hmm.
So it says 15, 15 right here, so now because it's good 3 times 15 equals 15, 15.
Mm-hmm. But did you not multiply the numerator? You forgot. Okay, get a sticker. Thank you for sharing. Okay, good. So we have to remember, right, that whatever we're doing to the denominator, we're doing to the numerator.
But even if you forgot to multiply the numerator, wouldn't it still be 5?
Yeah, but that's why we all learn differently, right? We all are understanding it differently. You know what I mean?
Way, like in a different pace.
Exactly, exactly. So now, let's do one for 1/5. What should be my equivalent fraction for 1/5 with my new denominator? Show me on your whiteboard. What's gonna be the denominator? Say it all together.
15.
The denominator is gonna be what?
15. Oh.
Hayden, what's the equivalent fraction?
15.
No, what's the equivalent fraction that we're creating? Show me on your whiteboard. Yvette. So, good, you guys. Yes, 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 good. Yes. Yeah. Good, 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 good. Okay, so if you, what if 5 times what gets me to 15? And whatever I'm doing to the denominator, I'm doing to the numerator. So that's 1 times 3 is? 5 times 3 is? Good. So that is 3/15, right? So I have 1/3, right, is equal to something over 15. What is my equivalent fraction here? 5 what? 5/15 is correct. Right? Okay. So now, if I want to create an improper fraction to subtract this, what is my new improper fraction gonna be? I know. Give me a second. We're gonna go right now. Yeah. Because now I have 15/15, right?
15
Plus 3/15
5/15.
minus 5/15. So what is it?
18/15 minus 5/15.
Minus 5/15. And what is that?
13/15.
13/15. Can I simplify this?
Yeah.
No.
No, right? So this is the simplest form. Yeah? When we come back, you and your partner will be working on C and D. Okay? You good? Okay, line up for recess. I mean PE.
I started recording at the application problem.
Oh my god.